Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2019 Test 5A Paper 1 Code A and B Physics. Let's move to question number 1. In question number 1, 2-point charges plus Q and minus Q are separated by a distance D. A particular electric field line emanating from charge plus Q at an angle 60 degree attains maximum height h above line AB as shown. If h is equal to under root x d by 6, then find the value of x. So if I analyze the situation, then these electric lines of force are originating in 3 dimensions. So the fraction of solid angle through which these electric lines of force originate from this point can be written as 2 pi into 1 minus cos 60 degree. This is the solid angle and its fraction is this divided by 4 pi. Since both the charges are of equal magnitude and opposite nature, then whatever the electric lines of force are originating from this plus Q, these all electric lines of force are terminating at charge minus Q. So due to symmetry, we can say that if I find a plane in between these two charges, then these electric lines of force which are originating from here are always incident perpendicularly to this plane. So let h is the maximum height, then in that case the solid angle of this plane can be written as 2 pi into 1 minus cos 90 degree. So the total solid angle for this plane is 2 pi and the fraction of the electric lines of force will remain same. So this is equal to, in the second case, if I write the solid angle, that can be written as 2 pi into 1 minus cos theta, and the value of cos theta can be found out if this is theta. So this can be written as cos theta is base, that is d by 2 divided by hypotenuse. Hypotenuse is under root of d by 2 whole square plus h square. So divided by 2 pi, because the total solid angle for this plane is 2 pi. So if I solve this equation, the value of h comes out to be root 7 d by 6. So on comparison, the value of x is equal to 7. So the correct answer for question number 1 is 7. Let's move to question number 2. In question number 2, a soap bubble of radius r, surface tension T, exists in equilibrium in vacuum. A monoatomic gas is trapped inside the soap bubble. Charge Q is given to the bubble such that bubble expands from radius r to 2r under adiabatic conditions. If the surface charge density sigma on surface is found to be under root 15 epsilon naught T by nr, then find the value of n. So it is mentioned in the question that the soap bubble expands from radius r to 2r in vacuum. So at t equal to 0, so in initial condition, the pressure inside the soap bubble P1 is 40 by r. And when the charge Q is given, in that situation, let surface charge density sigma on the surface, then I can write inside pressure is P2 plus sigma square divided by 2 epsilon 0, that is the electrostatic pressure, is equal to 4T by 2R. So that is equal to 2T by R. So in this situation, final pressure is P2 of the monatomic gas. We know that the expansion of the bubble occurs under adiabatic conditions, so we can write PV ki power gamma is equal to constant. So from here, P1 pressure is 4T by R, initial volume is 4 by 3 pi r cube raised to the power gamma is equal to final pressure is 2T by R minus sigma squared divided by 2 epsilon naught, that is the final pressure, into final volume. So final volume is 4 by 3 pi 2r cube. So I can write in this way 8 raised to the power gamma into r cube raised to the power gamma. So this term get cancelled out and the value of gamma for the monatomic gas is 5 by 3. So the value of 8 raised to the power gamma comes out to be 32. So if I solve this, then the value of sigma is equal to under root 15 epsilon naught T divided by 4r. So on comparison, the value of n is 4. So the correct answer for question number 2 is 4. Let's move to question number 3. In question number 3, a charged particle of mass m and charge q is released from rest from origin in a region where uniform electric field E0 j cap and a uniform magnetic field B0 minus k cap are present. Kinetic energy in joule of charged particle at the instant when it is maximum is n. Find the value of n. So we know that the Lorentz force F is given by Q into E vector plus Q into V cross B vector when the charged particle moved in the region of electric and magnetic field. So I can write this expression in this way. Since the motion of the charged particle in xy plane, so I can write in this way: m into dvx by dt into I cap plus dvy by dt into j cap is equal to q into E vector, that is E0 into j cap, plus q into V cross B. So the velocity is Vx I cap plus Vy j cap cross B vector, and the B is B0 minus k cap. So if I take the cross product and compare the LHS with RHS, then I can write m into dvx by dt is equal to minus q Vy into B0, and m into dvy by dt is equal to q into E0 plus q into Vx into B0. So in the given question, I have to find out the kinetic energy of the charged particle at the instant when it is maximum. So first of all, let's check at what instant it will be maximum. Since the path of the charged particle is cycloid, so it is something like this, and at this position it has maximum kinetic energy because the work done by the electric field is maximum up to here. Thereafter, the work done by electric field reduces the kinetic energy of the charged particle, and the magnetic field does not do any work on the charged particle. So this is the y maximum coordinate which the particle attained during its motion. So I want to calculate this value y max so that the kinetic energy can be written as q into E0, that is the constant force, into y max. So in order to calculate the value of y max, I have to find out the y coordinate. So I have to replace the value of Vx. So Vx can be replaced in this way. If I can write Vy as dy by dt, then from here on integration I get the value of Vx. That comes out to be minus q y into B0 divided by m. So if I substitute the value of Vx here, then I get the equation m into dvy by dt. I am writing in this way. I am multiplying and dividing this equation by dy. So dy by dt is Vy. So it can be written as m into Vy into dvy by dy. So that is equal to q into E0 minus q into B0 into Vx. So that is q into y B0 by m. So that is q square B0 square y divided by m. So if I separate the variables and integrate, then I can say that it is equal to m into Vy square by 2. So that is equal to q into E0 into y, because at t equal to 0, at x equal to 0, y coordinate is 0 and initial velocity is 0 in y direction. Further I can write minus q square into B0 square y square by 2m. So at the moment when the particle reaches to this position, the velocity is in this direction. So the vertical component Vy becomes 0 at this moment. So if I substitute the value of Vy to be 0, so from here the y maximum coordinate comes out to be 2m E0 divided by q into B0 square. So if I substitute the maximum y coordinate here, I get the kinetic energy at that moment, that is equal to 2 into E0 square upon B naught square into M. So if I substitute the data, so this is equal to 2 into 2 into 1. So it comes out to be 4 joule. So the correct answer for question number 3 is 4. Let's move to question number 4. In question number 4, in the circuit shown, switch S is closed at t equal to 0. At t equal to t naught, power dissipated in 2 ohm and 4 ohm respectively is 18 watt and 4 watt. If value of t naught is 4c by 3 ln x by 2, then find the value of x. So at t equal to 0, this switch S is closed. So let at any time t or t naught, the current in this is IC, the current here is I1 and the current here is I2. So from the data of the power dissipated in the given question, we can say that at time t naught, the value of I2 is equal to 3 times I1. Further, we know that from KCL at this junction, IC plus I1 is equal to I2. So if I substitute the value of I2 here, then IC comes out to be 2 times I1. So at this moment, if I calculate what is the charge on the plate of the capacitor, then I can write at any time t, Q as a function of time t can be written as C into V Thevenin into 1 minus e raised to the power minus t by R Thevenin into C. So by applying Thevenin theorem, we can find out the value of V Thevenin and R Thevenin in case of RC circuit. So in order to calculate the Thevenin potential difference across the capacitor at time t, I have to find out what is the potential difference between these 2 points. So that is also equal to the potential difference between these 2 points or the potential difference across the 4 ohm resistor. So that can be written as, at that moment in a steady state, the current will move in this circuit. So the current will be V0 by 6, and if I multiply by 4, that is the potential difference across the resistor. That is also the potential difference across the capacitor. So V Thevenin can be written as 4 into V0 by 6. So it comes out to be 2 V0 by 3. And in order to calculate the R Thevenin, we have to short the battery and find out what is the resistance across the capacitor at that moment. So if I short the battery, then 4 ohm and 2 ohm are in parallel. So in that case, the equivalent resistance will be 4 into 2 divided by 6. So it comes out to be 4 by 3 ohm. So if I substitute the data, so it comes out to be 2CV0 by 3 into 1 minus e raised to the power minus t by R Thevenin, that is 4 by 3. So 3 comes here into C. So this is the value of charge on the plate of the capacitor at time t. So at that moment, if I calculate the current IC, so that is equal to dq by dt. So that can be written as 2CV0 by 3. If I differentiate this, then it comes out to be minus e raised to the power minus 3t by 4c into minus 3 by 4c. So that is the value of the current in the capacitor. So in order to calculate the value of t naught or t at that instant, I can equate the potential difference across the capacitor at that moment is equal to the potential difference across the 4 ohm resistor at that moment. So the potential difference across the capacitor at that moment can be written as Q by C. So that is 2V0 by 3 into 1 minus e raised to the power minus 3T0 by 4C is equal to potential difference across the resistor is 4 into I1. So the value of I1 is IC by 2. So if I substitute the value of IC here and solve, then the value of T0 comes out to be 4C by 3 ln 5 by 2. So if I compare, the value of X comes out to be 5. So the correct answer for question number 4 is 5. Let's move to question number 5. In question number 5, 6 moles of hydrogen are mixed with n moles of helium. The most probable speed of gas molecule in the mixture is 2 by root 3 times the speed of sound in mixture. Find the value of n. We know that the most probable speed is given by under root 2 RT by m, and as per question it is equal to 2 by root 3 times the speed of sound in mixture. So that is gamma mixture RT by m. So if I solve this equation, the value of gamma comes out to be 3 by 2. Now we know that gamma mixture is equal to N1 Cp1 plus N2 Cp2 divided by N1 Cv1 plus N2 Cv2. We know that N1 is given in the question, that is 6 moles, and the value of N2 is N, which we have to calculate. The value of Cv1, that is for hydrogen, it is equal to 5R by 2, and the value of Cv2 for helium comes out to be 3R by 2. Similarly, we can calculate the value of Cp1, that is equal to 7R by 2, and the value of Cp2, that is equal to 5R by 2. So if I substitute the data here and solve for the value of n, then the value of n comes out to be 6. So the correct answer for question number 5 is 6. Let's move to question number 6. In question number 6, a particle of mass m connected to a string is revolving with linear speed v0 in a circle of radius r on a frictionless horizontal surface. The string is slowly pulled from below until the radius of circle reduces to r by 2. Tension in Newton in a string at that instant is T. Find the value of T. So we know that about this axis, the net torque is 0. So we can conserve the angular momentum of the particle about this, of the revolving particle about this axis. So from here we can write mvr is equal to constant, or vr is equal to constant. So initially v is v0, r is r, and that is equal to v final into r by 2. So from here the value of v final comes out to be 2 times v0. So at that moment the particle is moving in a circular path of radius r by 2. So the tension T at that moment can be written as m v square by r. So m is m, the value of v is 2 v0 whole square by r, and the value of r is r by 2. So it comes out to be 8 times m v0 square by r. So if I substitute the value of m v0 and r, the value of T comes out to be 8 Newton. So the correct answer for question number 6 is 8. Let's move to question number 7.